Hey guys and girls, and in today's video we're going to be talking about the random data type. We're then going to be using the random data type to create an infinite obby. Before we get started, you may be wondering what's the difference between Math.Random and the random data type. And the answer is there is no difference. You can imagine Math.Random as being a global random data type that can be accessed from any script. To demonstrate this, I can make a small script. So I'm going to say Math.Random seed equals 1, 2, 3, 4. And then I'm going to print Math.Random, and then I'm going to create a new random data type using the same seed 1, 2, 3, 4, and then I'm going to print the next number. And if I run the game, we can see that both random objects have both printed the exact same number. And if I change Math.Random to print a value between 1 and 100, and now I can change this to next integer and also tell it to print a value between 1 and 100. And now we can see that after testing the game, both random objects print a value of 33. If we read the random data type, we can see it says the random data type provides pseudo-random numbers. And we can see that pseudo means false, counterfeit, fake. So the random data type is providing fake random numbers. And if we look here, we can see that Roblox is using the PCG algorithm to generate random numbers. For more information on the PCG algorithm, we can look at Wikipedia, and we can see that there are many variants of this algorithm. And we can see that Roblox's variant is this one over here, and we can also see an example of this variant over here. So because random is not actually generating truly random numbers, we can actually generate the same random numbers over and over again. So here we can see I have random object 1 with the seed 1, 2, 3, 4, and I have a random object 2 with the same seed 1, 2, 3, 4. And if I run the game, we can see that random 1 generated these numbers and random 2 generated these numbers, which are the exact same as random 1. If I now change this value here to 50, like so, and if we now test the game, we can see that all the numbers have stayed the same, except that this one has changed from 29 down to 15. But the ratio has stayed the same. So here we have a range from 1 to 100, so there's a total of 100 numbers, and from here we have a range from 1 to 50, so there are a total of 50 numbers, which is 50% of 100. So what we can do is say 29 divided by 2 equals 14.5, and if we round this value up to 15, it's the same as this value over here. So you can think of the random object as an infinite long list of numbers that is predetermined by the seed number. And what's amazing about this is if we use the same seed for the random object on the server side and the random object on the client side, both the server and client would generate the exact same numbers without the need to send any information between one another. And here we can see that the server and client are generating the same numbers, and even without the need for any remote events or any kind of communication between the server and client, they continue to generate the exact same numbers forever. So let's now use what we've learned about random to make an infinite obby. So I've created a brand new base plate project. I've resized the base plate and I've created a part called start, and I have anchored this part. I've also put an arrow decal that faces downwards onto the start part, like so I can see the direction the part is facing in. And what I'm going to do now, inside of replicated storage, I'm going to create a number value, and I'm going to name this number value seed. And now, inside of serve script service, I'm going to create a script, and I'm going to name this script seed. And all I'm going to do inside of this script is set this number value to a random number. What I've done now is created two models, model A and model B, and inside of these models consist of three parts, but the two main parts are the start part and the end part, and I have the same in model B, and I've also put arrows on these parts the same I did with this start part over here. Now currently the models pivot around the center of the model, but I want the model to pivot around the start part. So an easy way to do this is the primary part. I'm going to click here and select the start part, and I'm going to do the same for model B. So now the model should pivot around the start part. And what I'm going to do now is inside of replicated storage, create a folder. I'm going to name this folder models, and I'm going to put model A and model B into my models folder. And what I'm going to do now is inside of replicated first, I'm going to create a local script, and I'm going to name this local script Obby, and I'm going to delete this line here. What I want to do now is get the models, but instead of using wait for child for every model individually, what I'm going to do is just wait for the game to finish loading. So I'm going to say if game is loaded equals false, then game.loaded wait. So this is going to wait for all the models to have been replicated to replicated storage before it continues. And what I'm going to do now is store all the models in a table. So to do this, I'm going to say local models equals game.replicated storage .models get children. The get children function will receive the models in an undefined order. So on one player, the order may be different from a different player. And in order for our script to work correctly, it's important that our models table are the same for all clients. So we're going to rely on the model's name to sort these models into order. So one thing we need to make sure is that each model has a unique name, and then we're going to use the table sort function to sort the models table. So we can see I'm using table sort, and then I'm passing in the models table, and we're passing in a function, and this function is checking the names between the two models in order to sort them. The next thing I'm going to do is store the start part in a variable. So I'm going to say local part equals workspace.start. And I also want to get the local player. So local player equals game.players local player. And let's also now create our random data type. So local random equals random.new. And now let's use the seed number value as the seed for our random data type. So what I'm going to say is game.replicatedStorage.seed.value. And what I'm going to do now is check the distance between the player's character to the part, and if they're within a certain distance, load a model from the models table. So I'm first going to get the run service. And now I'm going to connect a function to the heartbeat event. And the first thing I'm going to do inside of this event is make sure that the player has a character. So I'm going to say if player.character equals nil, then return. And I'm now going to check the magnitude between the player's character and the part, and if it's greater than 200, I'm going to return. So if part.position negative player.character get pivot.position magnitude is greater than 200, return. And what I'm going to do now is use the random data type to select a random index from the models table. So to do this, I'm going to say local index equals random, next integer, and we're going to select a number between 1 and the length of the models table. And now I'm going to use this index to clone the model. If you want to, we can merge these two lines of code together. So I can cut and replace the index with this. And now I don't need this index variable no more. And this is the exact same as it was before. And now I want to pivot this cloned model to the part. So I'm going to say model pivot to part.cframe. I'm then going to parent the model to the workspace. So what we're doing is we're checking the character's distance from this blue part, and once we're within 200 studs, we're cloning a random model like this model here, and we're pivoting this green part, because if we remember we set the pivot to the green part, which is the start part, and we're pivoting this model onto this blue part. Then I want to set the end part of the model, this red part here, to be the new blue part. What I'm going to do is update this part variable to be the model's end part. So I'm going to say part equals model.end. So if we now test the game, we can see because we're within 200 studs to the blue part, a random model was selected and cloned into position. Then the end part was set as the new part, and we're still within 200 studs of this end part. So it was cloned again, we're still within 200 studs, cloned again, still within 200 studs, cloned again, and currently this red part is outside of 200 studs. So if I walk closer to this red part, and once we're within 200 studs, it generates the next model. And it will continue to do this forever. And if we test the game with 2 players, we can see that both players generate the models in the exact same order. So blue, red, blue, blue, red. And if we look from the perspective of the server, there are no models because the models are being cloned on the client side. And if one of the players starts walking towards the models, we can see that this player is generating the models while this player is not generating the models. And if we look from the perspective of the server, the player is hovering in midair and no models have been cloned. And I can continue to keep walking. And now player 1 sees the other player as hovering as well. And if I start walking with this player, and we check the models that were loaded, we can see that the exact same models were loaded even though there's no information being sent between the clients and the server. Now currently there is a 50-50% chance to spawn either the blue or the red model, but let's say I wanted to spawn the blue model more often than the red model. So what I'm going to do is on the model, I'm going to add an attribute, and it's going to be a number, and I'm going to call this attribute chance, and I'm going to give the blue model a chance of 5, and on the red model I'm going to also add a attribute called chance, and this is only going to have a chance of 1. So let's now incorporate chance into our script. So the first thing I'm going to do is change the models table into children, like so. And then I'm going to create a empty models table, like so. And now I'm going to loop through every child. So I'm going to create a for loop. And now I'm going to get the chance attribute. So I'm going to say local chance equal child get attribute chance. And if we never set a chance value for that model, I'm going to just pass the value of 1. And now I'm going to loop up to the chance amount, and for every chance I'm going to add the child into the models table. So I'm going to say for I equals 1 to chance do, then I'm going to insert the child into the models. So what that means is I'm going to insert the blue model into models 5 times, and I'm only going to insert the red model 1 time. And if we now test the game, we should notice that the blue model gets selected more often than the red model. Let's now destroy these start and end parts, as there's not much reason to see them while we're playing the game. So once we have pivoted the model to the part C frame, we no longer need the model's start part to use as a pivot, so we can destroy the model's start part. And before we update the part with the new end part, we can destroy the old end part. So we can say part destroy. And finally, we can make this end part transparent, so you can't see the end part for the last model. So we can do model.endPart.transparency equals 1. And so now we should no longer see the start and end parts. And we can only see the end part here for the last model, but has a transparency of 1. What I've done now is created another model called Model C, and this model is almost identical to Model A and B. The only difference is I have a part within this model with the number of 50 as a name. And now inside of replicated storage, I'm going to create a remote event, and I'm going to name this remote event damage. And inside of starter player, starter character scripts, I'm going to create a local script, and I'm going to name this script damage. And inside of this script, what I'm going to do is connect a function to the humanoid's touched event, which will fire if any part touches any part of the humanoid. Then I'm checking to see if debounce is equal to true, and if it is equal to true, I'm exiting and doing nothing. I'm then converting the part's name into a number, and if the part's name is not a number, so number will be equal to 0, then I'm exiting and doing nothing. But if the part's name is a number, I'm then setting debounce to true, so that we can't enter the function again. And then I'm sending a remote event to the server, telling the server the number of the part that we touched. And then I'm waiting 1 second and setting debounce back to false, so that the touch event can bypass this if check on the next touch. Now inside of ServeScript service, I'm going to create a new script, and I'm going to call this script damage. And this script is going to be very simple. I'm just connecting to the on-server event for the damaged remote event. And if we remember, this is going to pass the player who sent the message and the number of the part they touched. And all we're going to do is deduct the health from the humanoid with the number that they passed. So if we now test the game, and if I touch one of these red parts, we can see that I lost 50 health, and we can see I lost another 50 health. What I've done now is created another model called Model D, and this model has a part called point, and inside of sound service I've created a sound group and added a sound which sounds like this. And inside of replicated storage, I'm going to create another remote event, and I'm going to call this remote event point. And inside of server script service, I'm going to create a script, and I'm going to name this script point. And here I'm going to create leader stats for the player when they enter the game. So I'm going to connect the function to the player added event. Then I'm going to create a folder which I'm going to call leader stats, and I'm going to name this leader stats. I'm going to parent it inside of the player, and then I'm going to create a int value and name this points and set the value to 0 and parent this to the leader stats folder. What I'm going to do now, inside of starter character script, I'm going to create a local script, and I'm also going to call this point. And here, what I'm going to do is clone this sound into the humanoid root part. So I'm going to say sound equals game, sound service, sound group, collect, clone, and I'm going to set this clone into the humanoid root part. What I'm going to do now is connect a touched event to the humanoid root part to detect when we touch a point part. So to do this, I'm going to say script.parent.humanoid.rootPart touched, and I'm going to connect this function. And inside of this function, I'm first going to check the part's name, and if it's not point, then I'm going to return and do nothing. But if it is point, then I'm going to play the cloned sound. I'm going to destroy the part that we touched, and then I'm going to fire an event to the server using the point remote event. And if we go back to the server point script, what I'm going to do is simply connect a on server event for the point remote event, and all I'm going to do is increment their point by 1. And if we now test the game, we can see that I have 0 points on my leader stats. And if I run over here and touch this point part, it plays a sound, the part gets destroyed, and my points increment by 1. And now you can get creative and start creating different types of models. So you can see here's some with some bends and turns, and with slopes and steps and obstacles. And you're not restricted to small models like this. We can even create very large models with houses, castles, buildings, whatever you can imagine. Let's now quickly overlook the project. So we have a number value called seed, and we have a script called seed. And all this script does is simply set the seed value to a random number. We then have a Obby script on the client side, and this script uses the seed to create a random data type, and this random data type is used to clone models. And this, because we're using the same seed for every client will clone the same model in the same order. We then have a damaged script in starter character, and when the humanoid touches another part, we check the part to see if its name is a number. We then pass that number to the server with a remote event, and then the server deducts the damage from the player. We also have a point script, and this is going to detect when the player touches a part, and if the part's name is called point, we play a sound and we destroy the part, and then we send an event to the server, and then the server will increment the points value by 1. Thank you for watching my video, and if you have any questions, feel free to leave a comment down below.